Hello there, this video will cover how to design and 3D print a cube from start to finish. This procedure will work on Androids, Chromebooks, and PCs. For this procedure, we will be using OpenSCAD to design a cube, Slicer to prepare the cube for printing, and then we will 3D print the cube. By the end of it all, we will have a 1-inch cube. This is a Media Blitz format that will allow me to share topics faster and keep pace with frequently updated topics. My channel focuses on adding the power of Linux to your Android, Chromebook, or PC without the need to root or remove your system. Additionally, I cover cross-platform topics. My playlists are available from the homepage on my YouTube channel and are organized by operating system and cross-platform topics. To make it easier to follow along with my videos, I include the full written instructions in the pinned comment. So if you scroll down to the comments of the current video you are watching now, you will see the top pinned comment containing the written instructions. To see the whole comment, click on Read More. Any updates will be noted at the top of the pinned comment. Note that you can copy and paste the notes into a text file like I have here with the mousepad text editor. Or, if you're feeling fancy, we can copy and paste the notes into a TiddlyWiki notebook, also known as Flexible Offline Searchable Notes. Here I pressed the backtick key from the top left of the keyboard so that there are 3 backticks before and after the text. This will apply monospaced block formatting. Keep in mind that you can modify the notes however you'd like, whether that's formatting, adding images, or changing what's in the notes. For more information on TiddlyWiki, I recommend watching my TiddlyWiki videos. That concludes the intro, now onward to the video. First, I'm going to give a quick overview on the process of 3D printing. First, we create a model with CAD software such as OpenSCAD or FreeCAD. CAD stands for Computer Aided Design. Once we've created our 3D design, we export the 3D model as a .stl file. STL stands for stereolithography. Then with the .stl file, we use a slicer program such as Slicer spelled with a 3, Ultimaker Kira, and so on. With a slicer, we define how to print the layers of a 3D model by making configurations based on the model being printed and the printer we are using. Then when we are done preparing the model, we export a .gcode file. G-code stands for geometric code. The .gcode file is what we give a 3D printer in order to print out the 3D model. In this video, the goal will be to design and 3D print a cube from start to finish. Documentation will be shown near the end of the video. For this example, I will be using an Android to create and prep the 3D model for printing. Again, this procedure will also work on Chromebooks and PCs. In order to create the 3D model and prep it for printing, we can first install OpenSCAD and Slicer. For this example, I will be using Synaptic Package Manager to install OpenSCAD and Slicer. To open Synaptic, we can go to the menu, and in the Preferences category, we can click on Synaptic Package Manager. Then when Synaptic is open, we can click on the Reload button near the top left to update the list of available software. When that's done, we can click on the Search button near the top right, and then we can search by name for OpenSCAD. When OpenSCAD comes up, we can right-click on it, select Mark for installation, and then click on the Mark button for the additional required changes. Then to install OpenSCAD, we can click on the Apply button, and then we can click on Apply again to confirm the install. Note that on Android, we can generally ignore install warnings and errors. So if we are using Android and we get an error, we can click on the Close button in the error window, and then we can click on the Close button in the Changes Applied window. Now to install Slicer, we can click on the Search button again, and this time we can search by name for Slicer spelled with a 3 instead of an E. When Slicer comes up, we can right-click on it, select Mark for installation, then we can click on the Mark button for the additional required changes. And finally, to install Slicer, we can click on the Apply button, and then click on Apply again to confirm the install. Again, for Android, if the install ends in an error, we can click on the Close button in the error window, and then we can click on the Close button in the Changes Applied window. Now that we are done installing software, we can close out of Synaptic. Now we are going to create a 3D model of a cube with OpenSCAD. To start up OpenSCAD, we can go to the menu, and in the Graphics category, we can click on OpenSCAD. Then from the Welcome window, we can open one of the examples by clicking on one of the drop-downs in the examples list, and select an example. For this example, I clicked on the Advanced pull-down, and then I selected Children.SCAD. Once we have selected our example, we can click on the Open Example button. Now for Android, if maximizing the window crashes OpenSCAD, then what we can do is drag out the corner of the window slowly to see how big the window can be made before it crashes. Once we figure out the point at which OpenSCAD crashes, we can open OpenSCAD again. Then from the Welcome window, we can click on the example we opened before from the list of recents, and click the Open Recent button. And then this time when we drag out the corner of the window, we can drag it out just before the point at which OpenSCAD crashed. Now in OpenSCAD, we can close out of the extra windows, which include the console, error log, and customizer windows. So now we have more room for the editor and preview windows. We can also resize the windows by dragging the edges of the windows. Note that the extra windows we closed can be opened again by going to the Window menu, and then we can uncheck Hide Console, Hide Error Log, and Hide Customizer. Now for the 3D model, we can rotate it by holding a left click and then dragging a finger on the mouse. To pan the model, we can hold a right click this time and then drag a finger on the mouse. To zoom in and out, we can click on the Zoom In and Zoom Out buttons near the bottom left of the preview window. To reset the view, we can click on the Reset View button that has a circular arrow in it. Now OpenSCAD uses code for 3D design. For example, to change the color of the cubes to purple, we can go to the 7th line in the editor, and then we can change the word red to purple. To see the change take effect, we can click on the Preview button that has a cube and 2 arrows in it. From here we should see the color of the cubes change to purple. Now that we understand the general idea of OpenSCAD, we are going to create a cube. To do that, we are first going to click on the New File button near the top left of the editor window. After that, we can close out of the example, and click on the Discard button if we made any changes. Now for the new file in the editor window, we can create a cube by typing in cube left parenthesis 1 comma space center space equal sign space true right parenthesis semicolon. This will create a cube that is 1 unit in length, width, and height, and it will also be centered. Keep in mind that OpenSCAD is unitless, so we will define size later when we prep the model for 3D printing. In order to see what we created, we can click on the Preview button at the top of the editor window. Then to see the cube more clearly, we can click on the Zoom In button at the bottom of the Preview window. So now we have created a 3D model of a cube. To save our project, we can click on the Save button near the top of the editor window. Then from here we can choose where to save the file, which for my case I will be saving the file in the home directory. And then we can also name the file. For my example, I will be naming the file cube.scad. After that, we can click on the Save button. Now in order to export the 3D model as a .stl file that we can use to prep the model for printing, we first need to render it by clicking on the Render button near the top of the editor window. The Render button will have a cube and an hourglass in it. Since the project only contains a cube, this will be instantaneous. For larger projects, it may take a few moments. Once the model is rendered, we can click on the Export as STL button. From here we can choose where to save the file as well as name it. For this example, I will be naming the file cube.stl. After that, we can click on the Save button. And now that we're done creating a 3D model of our cube, we can also close out of OpenSCAD. Here I am just opening a file manager where we can see I have a file called cube.scad and I also have a file called cube.stl in my home directory. Now we can use the .stl file to prep the model for printing. To do that, we will be using Slicer. Because Linux on Android currently cannot use OpenGL graphics, we will use Slicer from the command line. Again, this procedure will also work on Chromebooks and PCs. To use Slicer from the command line, we start the command with Slicer, which is spelled with a 3 instead of an E, and then we follow that up with the options we want to use for this print, and finally we end it off with the .stl file of the model we want to print. For this example, I will be creating a script for using the Slicer command. This can provide a way of remembering what configurations we've used before so we don't forget later on, and then we also don't have to retype every option we want to set. Note that you do not have to create a script in order to use Slicer. To create the script, we can execute nano space gocube. This will create a file called gocube with the nano text editor. From here, for the first line, we can type in Slicer, spelled with a 3 instead of an E, space \. So here we will be executing the Slicer command, and the \ will continue this line onto the next one. Note that the backslashes are not necessary and everything can be executed as one line. For readability and clarity, I will be using backslashes. So on the next line, we can type in --scale =25.4 space \. .stl files are unitless and Slicer assumes 1 unit is 1 millimeter. So in order to get an inch, we would need 25.4 millimeters. So for this example, we are creating a 1-inch cube by setting the scale to 25.4. Now on the next line, we can type in --skirts =5 space \. This will print out 5 loops of filament surrounding the object being printed. This helps with getting the filament flowing beforehand, so there's a good first layer. Note that you can use more or less skirts. After that, on the next line, we can type in --nozzle -diameter =the diameter of the printer's nozzle in millimeters space \. This defines the nozzle diameter of the printer we are going to be printing with in millimeters. For my example, I am using the Ender 3 Pro, which came with a 0.4 millimeter nozzle. Some potential places you can try looking from to figure out the diameter of your printer's nozzle are in any instructions that came with the printer, the box the printer came in. You can also look at the printer itself, or you can search online for the specs of your specific printer. Once we have that set, on the next line we can type in --filament -diameter =the diameter of your filament space \. This defines the diameter of the filament we are using. To figure out the diameter of the filament we are using, we can look at the spool of the filament to see if it's written on there. We can also look at the box the filament came in, or we can try measuring the filament with a caliper if you happen to have one on hand. Note that depending on the filament being used, you may need to set the -- temperature option in Celsius. The default temperature is set to 200 degrees Celsius, which works for PLA plastic, which is a common filament. Another common filament is ABS plastic, which requires a higher temperature to be used. Note that there are other kinds of filament, such as nylon and carbon fiber. Additionally, you may need to set the G-code flavor with the --G-code-flavor option. Using the wrong G-code flavor can result in the printer interpreting the G-code instructions incorrectly. The default G-code flavor in Slicer is set to RepRap. RepRap in this case refers to the Marlin and Sprinter firmware. Marlin is a commonly used open source firmware that's based on Sprinter. To find the necessary G-code flavor, we can look to see if it's written anywhere on the printer. We can also look at the instructions the printer came with, or we can search online for the G-code flavor the printer needs. For a list of G-code flavors available in Slicer, we can do man space Slicer spelled with a 3 instead of an E from a terminal, and from here we can scroll down to the printer options section and look at the available options for --G-code-flavor. After that, for the next line, we are going to type in -o space tilde slash mycube.gcode space \. This lets us define where to save the file as well as what to name the file. Note that this option is optional. By default, Slicer will save the file in the same directory as the STL file, and it will have the same name as the STL file, except the file type will be a .gcode file. Finally, after that, on the next line, we can type the name of the .stl file, which for this example is cube.stl. Note that we can input more than one .stl file at once. When we are done creating the script, we can do Ctrl-O, Enter, and Ctrl-X to save the file and exit Nano. Then from there we can execute chmod space +x space go cube. This will make our script executable so that we can use it. Now to execute our script, we can do /go cube. In the output, we will be shown where the file has been saved, and we will see the file name. So here I can see the file is in my home directory, and the file is called mycube.gcode. So from the home directory, if we execute ls to list the files and folders, we should see the mycube.gcode file. So now we can use our .gcode file to print our model. For Chromebooks and PCs, we can simply copy the .gcode file to external storage. For Android, we first need to copy the file outside of Linux in order to access the file from the Android side. To do that, we can open a file manager, and from here we can first right-click on the .gcode file, select Properties, then in the File Properties window we can go to the Permissions tab, and from here we can set all the access control dropdowns to anyone. This will make it so that we can copy the file from the Android side. Once we've done that, we can click on the OK button to apply our changes. After that, with the .gcode file selected, we can do Ctrl-C to copy it. And then to copy the file outside of Linux, we can go to the following file path, which is /host-rootfs/storage/emulated/0/Android, starting with a capital A, /data/tech.ula/files. Depending on the version of Android and userland, it may be necessary to create some of the folders in the file path with an external device. From here, I recommend bookmarking the file path for convenience so we don't have to type that in again whenever we want to copy files outside of Linux. If we are using the PCManFM file manager, we can do Ctrl-D to bookmark a file path. From here, we can do Ctrl-V to paste our .gcode file. Once we've done that, we can move the file to a more accessible folder so we can view it from other apps. To do that, we can open up Android Settings. Then from Android Settings, we can scroll down and click on Storage. Then from Storage, we can click on Documents. And here we can open with Files just once. Then from the Files app, we can click on the three-line menu from the top left. Select the device's internal storage. Then from here we can go into the Android folder. Then click on the Data folder. And from the Data folder we can scroll down and go into the tech.ula folder. Here we can click on the Files folder and we should see our .gcode file. To copy the file to a more accessible folder, we can hold a long press on the file. Then click the three-dot menu from the top right. Select Copy To. And from here we can copy the file to a more accessible folder, such as the Downloads folder. Once we've done that, we should be able to see the file from another app, such as the Google Files app. So from the Google Files app, I went into my internal storage. Then I clicked on the Downloads folder, and here we could see the .gcode file. Now that we can easily access the .gcode file, we can copy it to external storage. Note that depending on the printer, the storage device may need to be formatted as FAT32. I will show how to format external storage to FAT32 at the end of the video. Now to copy the .gcode file to external storage, we can first plug the external storage device into our Android device. Then we can click the three-dot menu next to the .gcode file, select Copy To, Then select the external storage device, and click on the Copy Here button. Note that Android will automatically make an Android file structure on the external storage device. These folders can be ignored. Once the file has been copied to external storage, we can eject the device by pulling down our notifications, and click the Eject button to unmount the external storage. Now we can 3D print the cube. For my example, I am using the Creality Ender 3 Pro printer, which I've had for a few years. Keep in mind, your printer may vary on the procedure needed to prepare for printing. So this is just a general example of how I prep the Ender 3 Pro. So depending on the printer, you may need to level the bed manually. So for my printer, I am first having it auto home so that I can start leveling the printer. After that, I disabled the steppers so that I can move the nozzle and the bed freely without resistance. So in order to level the bed, I need to turn the screws with the gears on the bottom. So near the four corners of the printer, I am checking and adjusting the level based on the resistance I get from putting a piece of paper between the nozzle and the printer bed. Ideally, I'm trying to make it so that the nozzle is lightly scratching the paper. So there shouldn't be too much resistance, but the nozzle should also be touching the paper. After that, I moved the printer head up on the Z-axis, and then I started preheating for PLA filament. PLA plastic is a common printer filament. If you're using a different material such as ABS plastic, then you'll need to preheat with a different temperature. If the printer has been used before, some filament will likely come out when preheating. This is why I moved the nozzle up so that it's easier to grab the filament that oozed out. With that being said, do not touch the nozzle, it is very hot. I like to use a pair of pliers to grab the filament once it's done oozing out so that my hand isn't anywhere near the nozzle. Once the printer is done preheating, I then extrude 10 millimeters of filament to ensure that the filament is flowing and to also get a better first few layers for the print. Again, I am using pliers to grab the filament that's been extruded. Now when we are done prepping our printer, we can plug in our external storage device containing the .g code file into our printer, and then we can select our file from the external storage device to start printing. So now we can sit back, relax, and watch the printer go. Note that the loops around the cube are the skirts that we set up when we sliced our 3D model. When the printer is finished, we can remove our cube and the skirts from the printer's bed. If there is a struggle to remove what we printed off of the bed, then we can try using a scraper of some sort to get it off. For this, I prefer to use a plastic scraper if possible. If there is a stray plastic-like hair where the printer finished, we can cut that off by using scissors, wire cutters, or we can even just pull it off with our fingers. So now we have successfully designed, sliced, and 3D printed a cube. Now how fun is that? For more information about OpenSCAD, we can go to openscad.org. Here we can go to the documentation page where we can see there's tons of documentation. So first, there's the OpenSCAD tutorial, which walks us through various examples and explanations of how to use OpenSCAD. After that, we have the official OpenSCAD user manual. From here we can see the ins and outs of how to use OpenSCAD. In addition to that, at the bottom of the documentation section, there's a cheat sheet. To save the cheat sheet, we can either take a screenshot or we can print the page to PDF. If we print the page to PDF, then I recommend setting the orientation to landscape. Here, after I've saved the cheat sheet as a PDF, I opened it with QPDF View. To get QPDF View, we can install QPDF View. Besides the official documentation, they also have links to books on OpenSCAD. One book that caught my attention was the Mastering OpenSCAD Within 10 Projects. This is an online book that we can read at no cost. This book explains and has examples which include this really cool looking pen holder, a whole intricate tree, and more. Also, in the documentation section of the OpenSCAD website, they have a couple of links to video tutorials. Here I clicked on the first one, which takes us to a playlist of OpenSCAD videos that get more complex as we go. Finally, from the OpenSCAD website, they also have links to articles for their documentation. For documentation on Slicer from the command line, we can do Slicer spelled with a 3 instead of an E, space -- help. This will give us a more brief form of the documentation for Slicer. From here we can also see what the default value is set to for each option. To get more detailed documentation, we can do man space slicer spelled with a 3 instead of an E. If we'd like, we can take what's in the man page and put it into a text file so that we can search it. To exit out of the man page, we can press the Q key. Then to put the man page into a text file, we can execute man space slicer spelled with a 3 instead of an E, space right angle bracket, space slicer spelled with a 3 instead of an E, -doc.txt. This will take the output of the man slicer command and put it into a text file called slicer-doc.txt. So now if we open a text editor such as Mousepad and then open the slicer.txt file we created, we can see the output of the man slicer command has been put into a text file. So if we're using the Mousepad text editor, we can do Ctrl F to do a find on whatever word we would like. For my example, I searched for filament-diameter and we can see the filament-diameter option that we used earlier. So this gives us an easy way that we can search for different options for Slicer. Keep in mind you can modify the text file however you would like. For more documentation on Slicer, we can go to slicer spelled with a 3 instead of an E.org. From here near the top right, we can click on the manual to get more documentation on Slicer. From here we can see how to use Slicer as well as get various 3D printing concepts and tips. Documentation on how to use Slicer from the command line can be found from the list on the left side under Advanced Topics, where we can click on Command Line Usages. If the terminal documentation does not match up with the online documentation, then I recommend referring to the documentation from the terminal that we looked at earlier. In this video, the 3D printer I used is the Ender 3 Pro, which as of right now is less than $200. Keep in mind there's a big variety of printers with various prices and features. Creality is the brand that makes the Ender printers. For filament, the price typically ranges from $20 to $30, give or take, depending on the type of filament and how many spools are being bought. There's even multicolored filament with fun, vibrant colors. Now I will cover formatting external storage on Androids, Chromebooks, and PCs. In my case, for the Ender 3 Pro, it was only able to read from an MS-DOS partition table that contained a FAT32 partition. First, I will cover formatting external storage with an Android. For my case, the following solution for Android formatted the external storage with an MS-DOS partition table that contained a FAT32 partition. To do that, we can first plug in our external storage device. Then after that, we can open up Android Settings. Then from Settings, we can scroll down and click on Storage. Then from Storage, we can click on the This Device pull-down and select the external storage. From here we can click on the 3-dot menu from the top right, select Format, and then click on the Format button from the bottom right of the screen. After that, we can click on the Format button to confirm that we want to format the device. Keep in mind that formatting the device will erase everything that's on the external storage device. When that's done, we can click on the Done button. So now the external storage has a MS-DOS partition table with a FAT32 partition. On a Chromebook, in order to erase the existing partition table, I used the Chromebook Recovery utility. Then to format the storage as FAT32, I used the Chrome OS Files app. To get the Chromebook Recovery utility, we can open the Chrome OS Chrome browser, then go to chromewebstore.google.com. From the Chrome Web Store, we can search for Chromebook Recovery utility. After that, in the search results, we can click on Chromebook Recovery Utility. Here we can click the Add to Chrome button, and then we can click the Add Extension button. When that's done, we can close the notification that says the Chromebook recovery utility has been installed. Now we can plug in our external storage that we want to format. After that, we can open the Chromebook recovery utility by clicking the Extensions button that has the puzzle piece icon near the top right of the Chrome browser. From Extensions, we can click on the Chromebook recovery utility, and then we can make the window full screen. Now to wipe out everything that's on the external storage device, we can click the gear icon near the top right, select Erase Recovery Media, then in the Select drop-down we can select our external storage. Once we've selected our external storage, we can click on the Continue button near the bottom right, then click the Erase Now button. When that's done, we can click on the Done button, which will close the Chromebook recovery utility. When that's closed, we can then also close out of the Chrome OS Chrome browser. Now to format the storage to FAT32, we can open the Chrome OS Files app, and if the external storage is not listed from the left side, we can unplug it and then plug it back into the Chromebook. If we click on the device, we will see the file system cannot be opened because we've erased everything. From here we can right-click the external storage, select Format Device, and in the dialog that comes up we can set the drive name, and then set the format to FAT32. When that's set, we can click the Erase and Format button. Now after the storage is formatted, if we click on it and see that the name is not what we had set it to be and the files that have been wiped out still exist, then we can click on the Unmount button that is to the right of the storage device, unplug the storage from our Chromebook, plug it back in, and now we should see the new name of the device and we should see there are no files on the external storage. So now we have successfully formatted the storage to have a FAT32 partition. Finally, on a PC, to format external storage to have a MS-DOS partition table containing a FAT32 partition, we can use gparted. If gparted is not already installed, then we can install gparted. So first we can plug in our external storage into our PC. Then in any pop-up windows that come up, we can click on the OK button, and then we can close out of any file manager windows. After that, we can open up gparted from the menu, and in the System Tools category, we can click on gparted. From here we will need to type in our password in order to open gparted. When gparted is open, we can make it full screen, and then we can select our external storage by clicking on the device drop-down from the top right, and then select the external storage. Make sure the external storage is selected because we do not want to wipe out our main system. Here we can see the types of partitions the device has. Before we format the device, we can also view what the partition table is set to by going to the View menu, select Device Information, then from the panel on the left we can see what type of partition table the device has. If the device is not already formatted to what we need, we can first unmount each partition by right-clicking on the partition, and select Unmount. When all the partitions from the external storage are unmounted, we can delete all the partitions by right-clicking on a partition, select Delete, and once all the partitions are ready to be deleted, we can click the green checkmark button near the top left to apply the changes. From here we can click the Apply button to confirm the change. When that's done, we can click on the Close button. Now to format the external storage as FAT32, we can click on the Device menu, select Create Partition Table, and then in the Select New Partition Table Type drop-down we can select MS-DOS. Once we've done that, we can click on the Apply button. After that, we can right-click on the unallocated space, select New, and from here we can click the File System pull-down, and select FAT32. From here we can also set the label. Once we've done all that, we can click on the Add button. Now to apply the change, we can click on the green checkmark button near the top left, and then click on the Apply button to apply the change. When that's finished, we can click on the Close button, and then we can close out of gparted. So now the external storage has an MS-DOS partition table that contains a FAT32 partition. Fun fact, RepRap is short for Replicating Rapid Prototyper, and it is a project for developing 3D printers that are low cost and can print most of their own parts. Here I got a chuckle out of the picture showing the parent machine that created the plastic parts for the child machine. Companion books to my series of videos are available. I will have those linked in the pinned comment. And that's all for this video, so thank you for watching, and I'll see you soon!